So when we say motion problems, we really talk about this idea that distance is rate times time. Okay, so let's see how we can do these problems. So an example of a problem might be like this. It might say that, you have a guy and he's going to the airport, right? And so they'll give you a lot of information. But the main idea is that you want to make a chart and plug in the givens. So that'll be step one. So make a chart that looks like this. This is our little formula, by the way. So distance, rate, and time. Okay, distance is just how far, rate is how fast, and time is how long. So, and then we're going to make a column for each of them. And this will be total. Okay? And so what we're going to do is we're going to plug in the givens. So they're going to give us a lot of pieces of information. Let's say to the airport, to the AP, and then to the office. So he goes from his house to the airport, and from the airport he goes to his office, okay? And so they gave us some information about this, but they asked us, find the distance the distance to his office. So they told us that it took 40 miles per hour from the airport to go to, he went by car and it took 40 miles per hour. And then to the office, it took 60 miles per hour, 60 mph. Okay, and they also told us that the total distance is 150 miles. They also told us the total time is 3 hours. But they want us to know what is the distance to the office. So, drawing a visual is very confusing. So the best way is just, in my opinion, to just draw a chart. So, from here, we don't know the distance to the airport. So we'll just say it's x miles. And so, but we can say the office in terms of x. What will we say? We will say 150 minus x. So doing this, we see x plus 150 minus x will give us 150, right? That's why we can say, if we call this one going to the airport x, then we can call going to the airport 150 minus x. And similarly, it doesn't matter if we call this one x or this one x. If we call this one x, this one can be 150 minus x. Either ways, when we add them up, they give us 150. Same thing here. We don't know the time. We'll just call it y. And this one will just be 3 minus y. Alright. So now what we're going to do is that we're going to use our little formula. And so we basically we plugged in all the givens. So we're done with step 1. Now we're going to use the formula distance equals rate times time. So rate distance 150 minus x. Let's just focus on this one then. Let's focus on this column. So over here we see that 150 minus x will be equal to 40 times y, so 40y. And if we also look at this column, we will see that x is going to be equal to 60 times 60 times 3 minus y. Alright, step number 2 is done. We just use the formula. And from here it's just algebra. Let's see what I mean. So we have 2 variables and 2 equations. So we can basically solve this. When we distribute this, we will get that it's 180 minus 60y. And then we solve for x and solve for y. And it turns out that x is actually going to become equal to 90. And that's our answer. The main thing we can take away is that how we label each box and the idea of making this chart to solve problems with a lot of information, okay? And we also should remember that, distance is always equal to rate times time, okay? Because if I'm going if I'm going 50 miles per hour, if I'm going 50 miles, right? And then I go for 1 hour, right? Then my total distance is 50 miles, right? This is my rate, this is my time, and this is the distance. Similarly, if I said distance, my rate is 50 miles per hour, but I go 2 hours, now I multiply them again, and I will get 100 miles. My distance is 100 miles. So that's kind of why distance equals rate times time, and that's why we solve those kind of problems.